Hello everyone, this is lesson S10 on satellites. First thing we're going to just quickly do here is we're going to define satellite, which is just an object which revolves around a planet. And so we'll write that down, an object that revolves around a planet. Remember, a planet is an object that orbits a star, and so this is an object that orbits or moves around a planet. Now, most satellites that we think about are actually artificial satellites, which is really just a man-made object orbiting a planet. But anything that's orbiting the planet will be a satellite. In this sense, the moon is a satellite of Earth because it is an object. However, it is not an artificial satellite. It's a natural satellite because it is not man-made. Now, there's two types that are used for communications. If you go to page 404 in your textbooks, it'll give you more information about that. But first type is a low Earth orbit. It will look something like this. Notice that this orbit does not always sit at the same spot over the Earth. It's just spinning around, going over different places as it goes through. The other type is the geosynchronous. Now, the geosynchronous is always set to be above the Earth at the same distance. And because of that, will not need to, the satellite dish that's receiving this will always be in the same spot. So let's put these kind of side by side. Again, so you can kind of just see the difference between your low Earth and your geosynchronous. Okay, so the low Earth orbits typically sit somewhere between 200 and 800 kilometers above the height of the Earth. They're very, but geosynchronous are at 36,000 kilometers above the Earth. Now, the length of one orbit here, typically for a low Earth, will be between 1 to 1.5 hours, where a geosynchronous takes 24 hours. Now, because this is spinning around the whole Earth in 1.5 hours, and it takes the Earth 24 hours in order to make one complete rotation, these are always moving across the sky. So these will appear to be a slow-moving shooting star. A slow-moving star across the sky. So if you've ever seen a slow-moving shooting star, that's really been a low Earth orbit satellite. Now, the 24-hour geosynchronous, because that satellite is takes 24 hours to go around the Earth, and the Earth takes 24 hours to spin, this is always in the same place. And so to the observer, this is going to appear as a star, a stationary star. However, at times it may disappear based on its relation between the Earth and its shadow. Now, because it's always over the same spot, usually as it goes from daylight to nighttime or nighttime to daytime, it's there, and it just kind of disappears within the night sky. But that is essentially what's happening there, where all the other stars will move across and kind of set. It's a star that always seems to stay in the same spot and disappear and reappear at morning and night. Now, low Earth orbits, they're typically used for telephone and two-way communications. And the reason for this is, also I should put surveillance as well. Now, the reason for the telephone or two-way communications is because several satellites can be there, but because they're so much closer to the Earth, you can get that feed off of the satellite and back in relatively short order. However, you do need many more of those satellites in order to keep the signal, because there will be times when, as it shoots across the sky, that one of those satellites will not be available. Surveillance is another one where one satellite, especially if you think about going with that polar type of orbit that we were seeing just before, it will, throughout a day or two, actually go over every single part of the Earth. And so it makes for a very good, it kind of does it in like wrapping, and just hitting each portion of the Earth each time. And so that's why it can be used for surveillance. Geosynchronous, a lot of times are used for radio / TV signals. And specifically, we're looking usually at one-way communication. In this case, it is much further, has a huge wide base, but it takes a lot longer for the signal to come up and back down to wherever it needs to go. And as such, using with a one set of communications, and usually you got, let's say, like a 5 to 7 second delay for the signal to get there and back. However, compared to the low Earth orbit, however, if you're dealing with a one-way communication, that's just the lag that you're going to have at the beginning, and then you're not even going to notice it. Whereas with a two-way communication, if you can imagine, after each statement is received, you would respond right back. The person on the other end would have that 5 to 7 second delay, as with, let's say, a satellite phone. Okay, so that's it for this portion of the classless video. I do have another YouTube video to deal with the GPS. You're going to watch that second video and then answer these questions for the GPS. All right, and we'll meet up in class to go over them. But watch the second video and we'll come back to it. I'll post the link within the description. Okay, so what does GPS stand for? It stands for the Global Positioning System. It was the U.S. military that put the GPS satellites into orbit, and it is the Navstar satellite system. Now, these are kind of like a medium Earth orbit satellites. Yeah, because those satellites sit around 20,000 kilometers. So they're definitely not geosynchronous, but they're not really low orbit. So we'll call them a medium orbit. And so these global positioning satellites, we've got all of them. There's always going to need to be at least 3 above the horizon at any point. But usually 4 to 7 can be found, but always at least 3. The information that they're collecting is the distance between the satellite and the receiver. Really, it's a time ping, and it's your receiver that's actually doing most of the calculation. But the main purpose of using a GPS receiver is to determine the location. And so a very precise need for signal, 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 and then it is your receiver that then takes that information, calculates it, and puts you wherever you are on its integrated map. Okay, you've got some questions to work on. Have a great day, everyone.